All right, so welcome to the night hacking tour. We're here in Stuttgart with JUG Stuttgart, and Werner Keil is going to give a short presentation on JSR 363. So welcome to the night hacking tour, Werner.
Welcome. Thank you. So yeah, I'm just going to show a little bit of code or the actual demos, no slides. So it's a real hands-on code experience. So JSR 363 has actually just passed the review, and now the executive committee started to vote. At the moment it looks quite good, but most of them are generally a bit lazy or have to ask their lawyers. So until everybody finally votes, it may take still a few days, but I think some people have already cast their votes in the last couple of days. And since we also did a presentation to the executive committee in January while we met in San Francisco, they were generally convinced that this makes sense for the Internet of Things era, so that Java also has something similar to other languages, let's say like C++ or F# that have proper units of measurement support for quite a while now.
Yeah, and that'll be helpful with, I'm going to show a bunch of embedded demos. So
yeah, so this is also very much about
this is a good tie-in. Good segue.
So I'm going to show a couple of different demos. The first one, those who were at Java Land or saw the quick video may find it familiar. That's a Java FX demo to demonstrate it for the desktop and for Java SE. So there's an Android application for unit conversions that's called flib. Actually, I'm not exactly sure why they called it like that, but it was quite natural to call the Java FX port of it fxlib.
Compilation there, Werner? Compilation error?
No, it's just signing. I don't think there's a compilation error. It's always signing. That will take a long time. Oh, yeah, it's still signing the chart. Unfortunately, it always does that.
Yeah.
Yeah. So it's okay. There it is. Yeah. So it's always signing the char so that you can even run it via Java Web Start, for example. That's why it took a little longer. So the fxlib application is modeled very closely after the Android app called flib. So it has a couple of buttons for different quantities. So what do you want to convert? Any suggestions? Yeah, then let's just start with a length. So I don't have any lambda examples, but wherever it's lambda-fied under Java SE, obviously if you have, I don't know, I think there was something that in some American restaurants, children that are under a particular height get free meals. So you could do something like this. Like I said, since it has to be compatible with Java ME8 embedded, which I'm also going to show briefly. There's currently no lambda, but the SE implementation of the API when run under Java SE8 obviously works with lambdas, since Java ME embedded 8 has not got lambda support for mostly size reasons. There won't be any lambdas if you run it in the ME8 way. But the API itself is cross-platform, so it should support both. So let's just take meters to feet. Yeah. So 3 meters would be approximately 9.84 feet, or this is actually the exact value. Anything else? Yeah, I think you mentioned about the airlines. So we could.
Yeah, okay. So one of the things which I have trouble with is you can see I carry a lot of hardware. My suitcase limit is exactly 70 pounds in the US. So I have to make sure I weigh stuff and get it precisely the right weight. But when I come here to Europe, they measure it in kilograms. And I think they give me about 30 kilograms. So which one's bigger, 30 kilograms
Depends
or?
on the airline, but I think 30 kilograms is a little, yeah. Try to spoil the answer. 30 kilograms is a little bit less than 70 pounds. It would be 31.75. So
yeah, so next time they stop me and they say, too heavy, I say, no. 70 pounds.
And actually, I believe when I came back from Los Angeles from Social Media Week and had a few goodies that I got there, I had to repack some of them. So in America, they looked exactly at the 70 pounds.
Yeah, when they stop you, you tell them, no, 32 kilograms.
But I think for most European airlines, at least inside the continent, it's usually only about 23 kilograms. But for example, Turkish Airlines has 30 kilograms. That's a rather exceptional case. Okay, so this was the Java FX demo for Java SE. So although we have some Raspberry Pis lying around here, I don't have one at the moment. Well, let's see if I'm lucky later on. So anyway, this was an example that we ran during the Java 1 embedded challenge. And after it was over, I also added some units of measurement magic to it. So this is running in Tomcat, but in the course of the embedded challenge, we were actually running Tomcat on a Raspberry Pi. So here, the heart frequency is basically mocked. Back at Java 1, I think you were also there. I strapped it around my own chest, and it was really measuring live data. Here it's mocked, but the important thing, which you'll probably only see in the console, is here it really measures it in a type-safe way that this is really 87 beats per minute. So there are 2 units, beat and minute, and then with an algorithm, the beat per minute is also done through division. So it is doing a division of 2 units, and then the result is a combined unit that is beat per minute in that particular case. But technically, from the API point of view, you could also just say it is a unit that you define as beat per minute. But to demonstrate how the APIs work here, I actually decided to do it with 2 different units that are then divided as a result. And from SE, now we actually have the right heart frequency. But as I said, this is just a random value. But when it's green, it's optimal. When it's red, it's too high. And when it's down there somewhere, then either something is wrong or the patient is dead.
Hopefully something's wrong with the hardware, not the patient.
And now the last one, which is not that visual, but nevertheless important, is the Java ME embedded example that most of it has been contributed by my co-spec lead for the JSR v2com in Brazil. So they ran a little demonstrator of what Java ME embedded 8 provides, and one of it is the so-called liblet functionality to provide reusable code inside multiple applications, and the other one is also a service. So this consists of a second application that provides a service, and here the temperature sensor is also mocked, but as you can see, this is measuring temperature, and that's represented here. The little ugly uppercase A that looks a bit like a Scandinavian character, that's according to...
If you want them to see, you have to lower your screen resolution.
Okay, I think there's a lens too, but yeah, let's try that.
I can only do so much cropping and zooming.
So you can't do it with the console. Okay, then let's...
720 height is ideal. Yeah, that's fine. Much better. Wow. Slightly
Okay.
better.
Yeah, so I hope the characters are somewhat readable. Otherwise, I'm not sure if NetBeans supports the lens down here.
Hold on a sec, I will make it bigger. Oh, there we go.
Okay. Yeah.
A little better.
So, yeah, the important thing is, as you can see here, it's degrees Celsius. The little character that's between the number and the degree sign, that's, I spoke to Terence Bauer, Javaland, and he figured it's probably still a bug. This is the first preview. I will try it with the second preview, and if it... So this is not a bug of our implementation of the API. This actually looks like it's a bug of the underlying implementation of Java ME8 embedded. I also discussed it in the 2 expert group calls, and at least Roger, who's the spec lead of CLDC 8, said that
we have no bugs.
In previous versions, he actually admitted or confirmed that per definition CLDC 8 is not forced to have full Unicode support. So, yeah, I only see one colleague of mine working at Thales, but between 2 different vendors, we also occasionally come across things where one vendor only supports ASCII or some different encoding, and the other one supports full UTF-8. And then if the 2 applications talk to each other, then of course sometimes it comes to very odd results. And this is somewhat similar here, but according to Terence, either the preview 2 and the final version should already have it fixed, and otherwise I will also file a bug.
Cool.
What is the target version of the JDK for that? Is it supposed to go into Java 9? Or?
It's supposed to be standalone, so there's a nice diagram where Terence recently presented ME8, and that's talking about third-party GSRs, whatever that is. That's basically GSRs that are not led by Oracle and that are not part of the ME platform. And so this is one of those. There was one for J2ME that we aim to partly replace. That was just called Sensor API for J2ME by Nokia. And that was also always an addition. So especially in ME and ME-EP, there are so-called profiles. It's a little bit like in Java 8, you have 3 profiles that are just the smallest version and then 2 that are bigger. In ME8, you can have a lot more different profiles. And if you have a particular profile that's, for example, targeting a device that has no UI, both the ME embedded JSR is fully modularized. We do the same here. So I hope... Is it sort of readable up here now?
I can make it bigger if you want something bigger.
If we make this part a little bigger, as you can see here, those are the parts of the actual API. Each of them is a Maven module. So the core is the one that's mandatory, and that is required as a minimum requirement. So that contains a couple of basic types like dimension, measurement, quantity, and unit. Those are the helpful additional functional interfaces that mainly make sense with lambdas. A few of them are also used by these basic types. So even if you cannot use lambdas, they would still be in the API. Some of them we could potentially consider making them optional too. And then all the other modules are optional because you may have some temperature sensor out there that has absolutely no UI, so it doesn't make sense to add formatting and parsing and UI representation. That's why the format bundle or module, again, is optional. That contains things like unit formatting and parsing. The parser is again a foundation for things. For example, you can use it with the unified units of measurement or different measurement systems. So the parser is then to be used with some of these. And then again, for example, we have UQM implementations out there already at a project that I lead at Eclipse called Uomo. And there, for example, it also relies primarily on the base types like unit and quantity. It does not need what's also an optional module, and that contains all the physical quantities that exist. And each of these is used via generics to ensure that operations are always type safe. So that, for example, you cannot simply take a mass and convert it into a length or vice versa.
Is there support for right scaling, like if I have 2,000 bytes, I can say give me the approximate unit size so that it's 2 kilobytes approximately, or that when I saw the angle that if I have 300 degrees and 400 degrees, it turns out to be 60 degrees at the result. There's some support for
So with bytes and kilobytes, there's full support for all possible prefixes, like not just kilo, but all others.
that I got, but so is there a function to say right scale, and my input is a 1 with 15 zeros, and this gives me the correct amount in gigabyte or whatever?
Do you mean a range or something like validation?
Okay, I take it offline.
Yeah. So one thing that's in the optional util package that I could also show some of the console demos, although they're not that impressive, but
Why don't you help me with my demos? Why don't you help me with my demos?
You mean by adding the JSR to them?
No, you're gonna run them.
Yeah. The one thing that we added that there's on Fork provided something that seems quite inspired by earlier unit APIs, including the JSR approach 275, that most of the members of the current expert group were also in that expert group, but at the time nobody knew that the Internet of Things existed, because the term at least was not defined by anybody at conferences or similar occasions. So at the time for Java SE 6 or 7, it was found to be too specific. So that's also why at the moment we do not propose it for Java SE to be included in a JDK. But for example, the ME targeted device access API, that's currently an Oracle proprietary API. Potentially this could be open source as a JSR in the future version of Java ME. And it's aimed at Java ME8 at the moment, but it is also potentially applicable to Java SE embedded. I think at the moment it's not supported there yet, but they plan to port it also. So this JSR is a good example where it works in both platforms already, as you saw. And if a future version of a particular SE or EE profile that's, let's say, scientific, feels that this JSR is a good foundation for it, then it may be part of it. But since we are talking about Java versions that will be more or less modular anyway, just say jigsaw, that's why at that point we don't say this has to be a mandatory part of the JDK, but it may be an optional module that a particular application can retrieve and use. For the ME part, the new functionality, the so-called liblets, is where we see most use for this JSR in ME embedded. That so the ME aspect of the reference implementation, and there may either be a hybrid reference implementation that works both on ME and SE, or if more feasible, there will be two. And then the ME side of it will be made available as a so-called liblet for Java ME. So that different ME midlets or applications can use it without having to duplicate the code every time. Yeah, like I said, there are still one or two console demos, but most of them are not that impressive. So I'm not sure if there was a demonstration of the range, for example, where I extended it for hurricane scales. I mean, I guess that's probably more interesting to the US South. Still want to see that, or are we short in time?
Demos.
Okay, so let's go to the actual devices.
All right, so thank you, Werner. So would you mind staying here and helping me?
No, of course. I mean, I already moved over to the embedded part, so I'm more than happy to help.
Yeah, okay. So I think that was a great segue to do demos. So here's a toy for you. Here. So does anybody know what Werner is holding?
I know it because I worked in Denmark.
Yeah. Well, first of all, who's the mascot here? What does he look like? Duke. Okay, good. So you guys know your Java characters. That's very good. And Duke is built using the Lego Mindstorms. That's not a good sound. Okay, Duke needs some surgery as well. He's been having a rough trip. But Duke is built using Lego Mindstorms EV3, and one of the cool things about the new version of Lego Mindstorms, which just came out, here, hold this guy for a sec, is that inside the brick here, it actually has a full ARM processor running inside of it. So I think it's a Satara 300 megahertz ARM processor. This is the reboot procedure. Remove the batteries.
So would this run ME embedded in the future version?
Yeah, so I believe you can run. We don't have an ME embedded distribution, but it should run fine on ME embedded. And what we're going to show today is SE embedded running on the Raspberry Pi or running on the Lego Mindstorms EV3. And the library we're using is called Lejos. So Lejos worked on the NXT and maybe the RCX. I think it worked on the RCX too. But in those two cases, they cross-compiled for the Lego Mindstorms. On EV3, there's actually a Oracle JVM, which runs on Lego Mindstorms. They have the links to download and get everything set up. And then you can be running directly on our buddy here, Duke, with Java SE. All right, that's a better camera shot. Okay, and another side effect of it running on this guy is that it's very slow. So we're going to hook him back up and then let him sit on the counter while we do demo number 2, because I'm very impatient. I'm not going to wait for Duke to boot.
So his wheels look like a Segway.
Yeah, he has 2 wheels, coincidentally, just like a Segway. 1, 2, 3, 4. Okay, Duke, go ahead and boot. The second thing we're going to show is Java running on the Raspberry Pi. So the Raspberry Pi is a really low-cost embedded processor. One of you is going to walk away with one of these. And it's a nice way of showing the capabilities of Java ME and Java SE both run on the Raspberry Pi. And it's currently our reference implementation as well. So all the new versions support Raspberry Pi. And on this guy, we have a little...
Want to change the title, or will it stay on this one?
It's the same recording. It's all good.
That's fine.
We have a little LED switch and all this stuff. And let's see. So first we need to give it some power. The Raspberry Pi, for power requirements, simply needs about an amp of power. So a good way to power the Raspberry Pi is to use a cell phone charger or a cell phone battery. As long as it supplies an amp of power, you're good for portable power for the Raspberry Pi. So it's booting now. Let's see how far I can hold it up. Okay. So there's little lights and stuff happening on the Raspberry Pi. I'm going to plug the LEDs in, which should not be lit up right now. So hopefully they will turn off soon. And we're going to try to hook up to him over this cable via SSH. So what I'm doing is I'm turning on internet connection sharing on my computer, and then we're going to give an IP address to the Raspberry Pi from this computer sitting here.
So via Ethernet, or
What do you say?
via Ethernet you have?
Yeah, so I have an Ethernet cable, and then I'm sharing the network via internet connection sharing on my Mac. So this guy will get both network and also an IP address from my computer, and then I'm going to SSH to him from the local computer here. Let's see. Here, now you guys can see exactly what I'm doing. Terminal. Let me get rid of that. There we go. Okay, let's see if we got an IP address for him. The other way to check is in the Finder. He should also show up as a device here, because I've turned on Bonjour on the Raspberry Pi, so he'll also show up as a device. Here we go, LCD test board. So we should be able to do SSH root at LCD test board. Raspberry Pis are very, very fast computers. You can tell by how long it takes to open up an SSH connection. Actually, they're much better for graphics. We're going to do a graphical example in a sec. They're much better for graphics than they are for stuff on the console. Oh, wow, he just doesn't want to talk to us. What an unhappy little bugger. Beep, beep, beep. Okay, unhappy demo number 2. We're going through these demos really quick. Okay, back to Duke. Here you go, Werner. Have Duke. So yeah, we have Duke, and he happens to be on the same network. Wow, I can't even get out of this. Okay. 10.0.1.4 is his IP address. He's responding, thankfully. And we need a second volunteer from the audience as well. Hand this to somebody.
Okay, once.
Thanks for letting me know. Yeah, you're just gonna, we're cutting your power. Okay, so on here, I've already copied over a jar file. You can develop right on desktop, and there's a JRun script which adds in the EV3 classes into the class path. And we're going to run EV3-way, which is a segue algorithm for the Raspberry Pi. So the way this works is, back to camera. Okay, so put him on the ground, Werner. Lay him on his back, yeah. And you see he has a little button in his hand? Press the button in his right hand. Duke has two hands, one of them with a button. Press the right button in his right hand.
Red button?
Now lift him up quickly on his wheels. Like a... All right, so that's the basic procedure. Lie him down, press the button, lift him up, and try to get him balanced a little bit. No, you have to lie him down first. That calibrates the gyroscope, so he has to be perfectly still. Now lift him up. All right, now what Werner wanted to do is he wanted to show you the internals of how Duke is constructed. So you can see there's one of the small motors for wiggling the arms, and it's a little hard to see, but inside of it is a gyroscope.
No Achillean inside?
No. And one of the trickiest things about doing the model like this is, I think this is like version 5 or 6 of Duke. And the first few versions wouldn't balance using the algorithm because his body wasn't rigid enough. So to get Duke to balance successfully on two wheels, you have to create a fairly rigid and stiff frame. So the wheels are quite tight, and then I did a lot of infrastructure to make sure that they don't move at all.
One side.
Yeah. Thanks. All right, so you ready again?
Try it again.
All right. So the way this operates is it's kind of an inverse pendulum. Whenever he starts leaning, it gets the angular velocity using the gyroscope and also his current angle, and it tries to compensate by moving back or forward. And it's not perfect, so that's why he stutters and like weird stuff happens. But for the most part, he's balanced depending upon the floor surface. So you have the remote in your hands. Come over here. Get a little closer to Duke because you know the battery's not that strong in that. So the way this works is the top two buttons move left and right, and each time you click it, it increments a counter. So point it at his buttocks where the IR remote is and try clicking one of them. Get behind him. Yeah, behind him. And try clicking the left and right arrows. Maybe get a little closer. Yeah. No. Okay, so sometimes the IR remote has issues. And there's a very, how do you guys fix stuff that works intermittently at work? Like if you have a test that doesn't pass, you just run it again, right? Okay, so yeah. Pick up Duke, Werner. Grab Duke. Okay, and I kicked off the program a second time. And we'll try it again.
So.
All right,
So
you know the drill?
Yeah, it's like
Set him
a
down.
little baby that needs to have the pampers changed.
Click it again. Maybe the program wasn't started.
It's beeping. Yeah.
All right. And now try getting left and right buttons on the top. Oh, there you go.
Right.
All right, now press the big button to stop him. The top, yeah. And then the bottom ones go forward and back. So same thing. Don't hold them, just click them. Yeah, and the big button to stop him. Yeah. All right. You must have driven RC cars as a kid. You drive radio control cars?
Yes.
Yeah. You're doing quite good. It's not easy to control him, so.
Are the kids doing that at DevOps for kids too?
Yeah, but they only crash Duke. They don't actually drive. Okay, all right. Give our volunteer a big round of applause. Pick up Duke again, Werner. Go chase him. Yeah, question?
How about the garbage collector?
Okay, yeah, it's a good question.
Or what's the solution?
So on a big processor like this, there aren't a lot of, it's powerful enough to do real garbage collection, so it's not like a small embedded chip. But you still hit situations where you have pauses in your program. And the solution is if you really need to do something where you don't have garbage collection, you're doing something real time, you should do it at a lower level than from your Java code. So like don't use Java code to like run the motors in your quadcopter.
So it will fell over every other day or so if the garbage collector jumps in with the stop all.
Well, I mean, the garbage collector is fast enough that it doesn't usually.
Okay, yeah. As
Yeah.
long as the heap is small.
Yeah. And I don't have a large heap on this. It doesn't have a lot of memory.
Yeah.
So for most applications, it's quite fine to have a few small GC pauses going on. But if you're really doing something real time, like doing motors on a quadcopter, you probably don't want to do that from your embedded Java code. You probably want to do that on a native API. And you can access native APIs just like you do for desktop using JNI. Okay, let's see if demo number 2 is happier.
By the way, angular velocity is also among the types that are supported by JSR 363. So if the Lego API provides that in a way that's readable, then
Yeah,
we can
you
also
should.
do something with that.
You should update the segue code. It's open source. Give it a try.
Yeah, most of our stuff is already on GitHub as well. I have no slides, but if you look at units of measurement, either unitsofmeasurement.org, that still contains the old API, but a pointer to the new JSR page, or if you look on both GitHub and java.net have projects or communities that are each called units of measurement, and you will also find, especially on GitHub, you'll find every single demo that I have presented here today. And you can run it yourself if you want.
Okay, and what about the Raspberry Pi? Node name nor server name provided or not known. That's a wonderful error message. Here, you can watch me hacking. So I rebooted him and we're trying him one more time. If that fails, we have another Raspberry Pi demo. So this is the Duke pad. Oh wait, it worked. We have a login now. Okay, we'll get to the Duke pad. We'll still show that. Yes, we're logged in, and we're gonna see how strong Werner is. Are you feeling particularly strong today?
Well, at Javaland, I had to chase behind a 4-year-old who was trying to explore all of the venues. So yeah, he was definitely heavy on Duke.
Yeah. All right, so we have JDK 8 running on here, and we're gonna run a jar file from. Let's do the force sensor first. We'll see how strong you are. And these all run using Java SE embedded.
That should be quite interesting for JSR 364
Okay.
as well, yeah.
All right, now grab that.
Fingers or?
Yeah, fingers. 1300, 1400, pretty good.
May I ask what unit that is?
That's the raw data from the sensor unit.
Okay. Yeah,
All right, you're doing okay. Last night, our attendee got above 1,500, that's the highest I've ever seen it go.
Where was that?
That was in Darmstadt.
Oh.
Okay, so that's an example of the force sensor, and we're also going to show the LCD Pi plate.
So it's not a particular unit of pressure. It is literally just a. So if we wanted to use something like that with the Unity API, we would have to calibrate it and actually ensure that a particular value is mapped to an appropriate SI unit.
Yeah, okay. So I'll try to get the camera close enough that you guys can see what's going on. And someone else from the audience want to take a try at this? Yeah, come on up. So just come over here and give it a try.
Oh.
The force sensor is this guy right here.
Black one.
No, this one.
No,
this one
the
here.
black.
Here, okay.
All right, and we can't exactly see the values on screen, so read them out for us. What are you getting?
1567.
Wow.
Oh,
That's pretty
one of
good.
The guy in Darmstadt.
Yeah, and then try to cover the light sensor here and see how low you can get the second one too.
That's like 80, 76.
Yeah, not bad. Okay, give him a round of applause. Okay, and the last demo we're going to show is the Duke Pad. And I know this works because it's already up and running. So the Duke Pad is a tablet created with a Raspberry Pi as the basis for it. And it has a Pi camera and some other hardware inside of it. The case was actually designed by Jasper Potts, and we laser cut them at the local tech shop. So all the designs are online if you go to the Duke Pad website. And then you can actually build this whole thing yourself just using an off-the-shelf touchscreen and Raspberry Pi and battery. And there's even an open source user interface for Raspberry Pi.
Why is the date just something like, must have been a Java one, so it's not the current date?
Yeah, okay. So Raspberry Pis do not have battery, they don't remember their dates because they don't have batteries. So they connect to the network to get the current time, and we hard-coded it to be correct once. Okay, so universal number, everyone knows that. We can do calculations. We can do 3D, maybe. 3D. Okay. So here's a 3D cube using JavaFX 3D. I mentioned that as one of the new features in Java 8. We can also do interactive stuff like games. So this is the fossil game. Are you any good at this game, Werner? Here. See if you can beat the first level. So just click on stuff and it will blow up.
It's almost the same? No. So it's like Minesweeper.
I think it has to be like 3 or more together of the same type. Or bombs are good. Click on the bombs.
Oh.
Yeah. There's another one. Go for the bombs. Bomb. Very nice. Wow. Combos level complete. Good job.
Oh.
All right, and the last thing which Raspberry Pis are really good at, you wouldn't think about this given how bad they are in processing stuff, but they have really good GPUs in them. So they make great home entertainment centers. And this is full, 1080p video playing off the Raspberry Pi's little GPU that's integrated on the chip. So you know what movie this is, Werner?
Yeah, I've seen it.
You've seen it?
Yeah.
Yeah. Is it any good?
No. Nice. I think the first two ones were better, but it was okay.
Okay. Larry's son would be very pleased.
I didn't see any Oracle ads in the third one, but maybe I missed them.
You probably missed them. I'm sure we had an Oracle ad in there hidden somewhere. All right, so that is a quick overview of what you can do with Java Embedded. So just some wrap-up items. The Java Mag issue for March and April is out. It includes Lambdas and Nashorn, date and time APIs. Caroline, the editor for Java Mag, is interested in getting some folks to write for the magazine. So if you're interested in doing magazine articles, you don't need to be a professional writer. Just let me know, come up to me after the meeting, and I'll introduce you to Caroline. You going to write an article, Dominic? All right. Nice security article.
Well, I think V2Com was also included in the current one.
So also there's a developer challenge going on. And to decide who, so you can win one of 9 free passes to Java 1 by participating in the developer challenge. All you need to do is come up with an Internet of Things or embedded Java application. Show it running on the Raspberry Pi. I think there's a video involved to show exactly what you built, and then you could win a free trip to Java 1 plus expenses. And the deadline for the contest is May 30th for entering the contest. So to figure out, oh, and this is a gift from Yolan, who runs the contest. So she gave me some Raspberry Pis to give out. So to figure out who gets the Raspberry Pi, Werner is going to ask you guys a very tough question about either lambdas or units or whatever he wants. And the first person to guess correctly or guilt Werner into agreeing wins. Okay, and then while he's thinking about that, the last thing I want to mention is Java 1 San Francisco. So I'm the conference chair for Java 1. So if you're interested in presenting, the call for papers is open. And we just opened registration Wednesday, I believe, for the conference. And there's a special promotion running for $600 off, which is a special deal just for the Java 8 launch. It's lower than what we usually discount the ticket to, and I believe it's valid for the next few weeks. So if you're interested to come out for Java 1, I'd highly recommend to book early. Hotel prices do not get cheaper as it gets closer. And it's a great conference to attend and find out more about this stuff. Okay, so again, information about me and our question. Werner, if you have to look up the answer, then it's probably too hard for attendees.
So, yeah, you know the answer to universe, life, and everything? Okay. Now,
I don't have that many pies to give to everyone. We just have to.
that was not the. How many degrees Celsius are 42 Fahrenheit? Let's just say whoever gets closest.
10, 7,
7-ish.
Oh,
6, 2, 8.
who said 6?
Okay, winner.
So
Here.
it was closer to 6 than 5, yeah. 5
All right,
6.
so thank you, everyone. And if you want to look at any of the demos, feel free to come up. Otherwise, have a good evening.